All right, welcome back to part 2 of Notes 11.45. Now we're going to be talking about circle area. So remember that the area of a circle is pi r squared. Here you're given a radius. I need you to find the area. Go ahead and do that and come back when you have your answer. Hit pause now. All right, so you should have gotten for your exact answer 17.645 pi, 17.64 pi meters squared. And that answer is perfectly fine to me because our radius had a decimal in it. Now, if you want to be super duper exact, then you would go ahead and you would convert that to a fraction. So this is like the ultimate answer, 441 over 25 pi meters squared. So this is acceptable. This is the best answer. And this one, because I did not specify, is not an acceptable answer. The approximate area for the circle is 55.42 meters squared. However, if I don't specify, that is not the answer I want. So although it is true, it is not right for this problem. Moving on. So they ask us to find the diameter of a circle, and we know the area of a circle. Now, we do not know a formula that relates the area to the diameter, but we do know a formula that relates the area to the radius. So we're going to need to solve for radius and then go ahead and find the diameter. And notice that our area is in approximate, just something to keep in mind. So my area, 201, equals pi r squared. So we need to go ahead and solve for the radius. So I take 201 and I divide it by pi, and those cancel each other out, and then I'm going to take the square root of that. Again, I am dealing in approximate from the very beginning. Also, radius is always measured in approximate units. We don't leave it in terms of pi. So we are going to go ahead and do this in our calculator. So we can do it all in one step if we want to. And we can take the square root, so second square root of 201 divided by pi. And we get 7.998. So basically, we are talking about my radius is approximately 8 inches, which means that my diameter is approximately 16 inches, and that is my solution. Okay, just like we did when we had our arc length, we set a proportion that was part over whole equals part over whole. That is the same thing when we're talking about sector area. So sector area is like the shaded area, this little piece of pie here. It is part of the whole area of the circle. So if we are talking about sector area, then it is my part of the circle. So this would be my whole of the circle. So it would be my area of a circle, which would be pi r squared. And then this would be my part of the degrees. So this would be my central angle or my arc measure, depending on which one I'm given, over the whole number of degrees. Okay, and then this is just this formula solved for the area of the sector. All right, let's go ahead and use this. So we need to find the area of the sector formed by angle RQS. All right, so we are looking for the area of the shaded region. So we're going to do our part over whole, 63 over 360, those are my degrees, equals, the thing that I'm looking for is the sector area over the whole area of the circle, which would be pi times 5 squared. Now, sector area, just like whole area, is going to be left in terms of pi unless you're told otherwise. So we are going to go ahead and we are going to take and solve for x. So we get 360x equals 25 pi times 63. So we're going to take x, and it's going to equal 25 times 63 divided by 360, and then we are going to tack pi on the end. So we're going to go ahead and type all that into our calculator. And we take 25 times 63 and we divide by 360, and we get that, and we hit math, enter, enter, because we want the most exact form, and we find out that it's 35 over 8. So I get 35 over 8 pi, and this is sector area, so it is going to be in units squared because we weren't given any units. And that's how you work this problem. All right, word problem. So we've got a contractor and he needs to cut out a section out of a rectangular piece of wood as shown, and we need to know the area of the remaining woods. We need to know the area of the shaded area. So it's basically this rectangle right here, which is 11 by 7. So it's the area of that rectangle, 11 by 7, and I need to subtract out the area of this. And the area of that is basically this square right here, which is 3 by 3, plus this half circle. So 1/2 the area of the circle. And the area of this circle would be pi radius squared. The diameter is 3, so the radius is 1.5, and we got to square that. All right, so this is essentially my problem, and it says to the nearest square inch, which means I can do my approximate answer, which means theoretically we should be able to plug all of this into our calculator. So let's go ahead and do that. Follow along with me. So pull up my calculator here. All right. So I need to do 11 times 7. I can do that in my head. 77 minus, and I'm going to open some parentheses. So 3 times 3 is 9 plus 1/2, so 0.5 times pi times 1.5 squared, and I'm going to close some parentheses, and I'm going to hit enter. And I get 64.46, which rounds down to 64, and that's my answer. So approximately 64 inches squared. As straightforward as that. All right, let's find some more areas. I love this section of it. It's so fun. Okay, we need to find the area of the shaded sector. Well, the shaded sector is all of this. So we're going to go ahead and use our proportion, except instead of using 60, I'm going to use all the rest of this. So if this part's 60, the rest of this must be 300 degrees. So that's what's going to go in my proportion. So 300 out of 360 equals my area of my shaded sector out of my total area. My radius is 8, so we're talking about pi times 8 squared. And we're going to go ahead and we're going to solve this guy. So 360x equals 300 times 64 pi. So divide by 360. And we can go ahead and we can do it all in our calculator. So I'm going to pull up my calculator here, and I'm going to clear everything out. All right, so I take 300 times 64, and I'm going to divide by 360, and I get that, and I hit math, enter, enter, and I find out it is 160 over 3 pi. So 160 over 3 pi, and that is in meters squared, because that is the area of my shaded sector, and that is the exact answer. All right, moving down to this next question. So we've got the circle, it's got a radius of 6, and we need to find the area of the shaded segment. So what process would you do to solve this? I want you to think about that right now. Pause it, think about what your exact process is, write it down, and then come back and check and see if you're right. So hit pause now. All right, so hopefully you've thought of a process, and it should be something along the lines of this. Find the area of the circle, divide it by 4, because we really want to know what the area of this segment of the circle is, and then we're going to subtract the area of the triangle, and that will give us this little shaded area right here. So let's go ahead and do that. Okay, so the area of my circle is going to be pi times 6 squared, and I'm going to divide that by 4 because this is a 90-degree angle. All right, so that's 36 pi divided by 4, which is 9 pi. All right, that is the area of my circle, and then I need to subtract the area of my triangle. Well, the area of my triangle, fortunately for us, it is a right triangle, and furthermore, it's an isosceles right triangle, and both legs are 6 because they're both radii of my circle, so I can do base times height divided by 2, which means that I've got 6 times 6 divided by 2, so I get my 9 pi. 6 times 6 is 36, divided by 2 is 18. Can I combine these? No, I cannot, because they are not like terms. One of them is multiplied by pi, one of them is not. They are not like terms. What I can do is I can say that their units are meters squared. All right, so 9 pi minus 18 meters squared. That is the exact answer for this problem. All right, last problem of these notes. So we've got circle X here. It's got a radius of 8. And we need to find the shaded area. So what will your process be to find the shaded area? Well, if you said take the area of the circle and subtract the area of the triangle, then you were right. All right, so area of the circle is very straightforward. It is pi r squared, so it is pi 8 squared. Let's talk area of the triangle. All right, what kind of triangle do I have here? Well, these two sides are congruent, so that's nice. And furthermore, I know that these two sides are congruent because they're both radii of the circle. So what I really have going on here is an equilateral triangle. Now, there are a bunch of different ways I can find the area of this. So for example, I know that this is 60 degrees. So I could use a side angle side area formula. However, if you'll remember back, we said if you can use radicals, must use radicals. So here's one of those cases where it applies. So what we really need to do is find the area of this circle by using something that's going to allow me to use simplest radical form. So let's drop an altitude. And that means we have a base of 8 and we have a height of, well, if this little piece of it is 4 and this is 8, then this is, because it is a 30, 60, 90 right triangle, 4 radical 3. So the area of my triangle is going to be my base 8 times my height, 4 radical 3, divided by 2. All right, so this simplifies to 64 pi. This simplifies to 8 divided by 2 is 4, so 4 times 4 is 16, 16 radical 3, and the whole thing is in centimeters squared. And believe it or not, even though it looks very, very complicated, this is the exact form of the answer to this problem. So this right here is my answer. Be sure you understand how to do that problem for upcoming quizzes and tests. All right, that concludes notes 11.4-5. If you have any questions, be sure to ask about them in class and make sure you go on and do the notes check. Thanks.